we're talking about sum and difference formulas today, and tomorrow we talk about like double angle formulas. So the next two sets of notes are just filled with formulas. Good news. For the quiz on Friday, you do not have to have formulas memorized. For the test next Wednesday, you do not have to have these formulas memorized. So these formulas are longer than usual. Okay. So we don't expect you to necessarily memorize them, but we do expect you to be able to use them. So that's why I'm gonna stress the importance of doing your practice problems. That's how you know that you can actually use this formula before you come in to take that quiz on Friday. Okay? So they'll be on the quiz and on the test and available to you. You will still be responsible for section 5.1 and 5.2 identities. Pythagorean identity, quotient identity, reciprocal identity. Okay? So on the front of the flaps, you see the sum and difference formulas, and you've got 3 flaps. The first one is the sine formula. So this means if you have 2 angles, u and v, right here on the left side. If you're doing the sine of u plus v, so that's a sum formula, or the sine of u minus v, that's the difference formula, then you follow the stuff on the other side. Now notice the other side also has this plus or minus. So as long as the plus or minuses match from left to right, it just means keep the sign. So for example, if I were working a sum of 2 angles, so I have some angle u and some angle v, and I'm adding them together. Then when I plug into the formula on the other side, I'm going to have the sine of u times the cosine of v, and I keep the sign plus sine v times cosine u. Now notice when you're looking at your second flap and you see your cosine formula, the plus and minuses don't match. It's plus and minus on the left, and it's minus plus on the right. So that means if I were doing a cosine, and it was the sum of 2 angles, the cosine of u plus v, on the other side, it would be the cosine of u times the cosine of v minus the sine of u times the sine of v. So basically, whatever 2 operation signs are on top are part of one formula, and the 2 operation signs on bottom are part of the other formula with difference. Does that make sense why they're written differently? So you've got to choose on the right side when you're actually plugging into the formula. You've got to choose, should it be the same sign or should it be a different sign? You can also look at and see some similarities and differences from sine to cosine. So in the sine formula, you're multiplying a sine of the angle u times the cosine of angle v. But then when you're doing cosine, the first step is to take a cosine times a cosine. So those would be things that, if you were required to memorize a formula, you'd have to be thinking about what's similar, what's different. Okay, but they'll be there for you on the quiz. And the last one on the front, just take note for the tangent. Tangent is written as a fraction, so it has a numerator and a denominator. And then when you look at the signs, you've got plus and minus on the left, and then in the numerator, it also looks like plus and minus. So if you're doing a sum of 2 angles, then the numerator will be a sum. It'll be plus. In the denominator, it switches. It's minus plus. So then if you're adding in the numerator, you're subtracting the product of the 2 tangents in the denominator. Okay? So if today at any moment in any of our examples you are questioning what operation sign to put, a plus or a minus, you raise your hand or talk to your group members and kind of get that figured out so that you can choose the right one when it comes to the quiz on Friday. Okay, let's open the sign flap of your foldable. We're going to illustrate what is this sum and difference formula used for. Okay. So the first one on the back of the flap says the sine of pi 12. Okay. Now at this moment, if I ask you what is the sine of pi 12 without your calculator, you can't do it because it's not on the unit circle, right? The only questions I ask you without a calculator are from the unit circle. The sum and difference formulas allow us to find exact values or evaluate without a calculator if we can create the angle we're looking for by adding or subtracting two angles from the unit circle. So when you're looking at pi 12, that's a pretty small angle, right? And when I think about it, it's most like the angles in quadrant 1, right? So think about the angles in quadrant 1, pi 6, pi 4ths, pi thirds, maybe I'll go up to pi halves. Can you take any two of those angles, add them together, or subtract them, and get pi 12ths? So talk to your group members. How would you find out if adding or subtracting any of those two angles would get me pi 12ths? Can you come up with a pair? It could be from different angles on the unit circle. No, they don't. I'm just thinking like pi 12 is pretty small. It's less than pi 6. So I probably don't need to use the biggest angle. What am I doing on the board? Getting common denominators, because if I were going to add or subtract those angles in radians, I would need a common denominator, right? Can you pick out any two angles that would then give us pi 12? Maddie, which one? Pi over 3 and pi over 4. If we do pi over 3 minus pi over 4, that's 4 pi minus 3 pi over 12, and we will get pi over 12. Let's do that. So I'm going to write, this is really the sign of pi over 3 minus pi over 4. So in reality, that's probably like the hardest part of getting started on these problems is like you've got to figure out what two angles actually add or subtract. And if it's hard for you, get common denominators or think about common denominators. I heard some groups maybe talking like maybe they were thinking in degrees instead. Okay, that works. All right, now we're going to plug into the formula. So my u is pi thirds and my v is pi fourths. The nice thing about the formula is those plus and minuses in the formula take care of all your sign issues, positive and negative, so your angles are always really positive angles. Okay. All right, what does the sign formula start with? What do I do first? A sine of u times a cosine of e. So I'm just following the formula. And then I have to look at this sign. This is a difference of two angles, and the sign formula tells me I should use a subtraction sign. And then what do I do in the next set? Cosine of u, so now it's cosine of pi over 3 times sine of pi over 4. Any concerns about how I substituted into the formula? I mean, once you figure out what angles will work, it's really kind of like a plug and chug. These are now things that you can evaluate. What is the sine of pi thirds? Radical 3 over 2. And someone besides Abby tell me the cosine of pi fourths. Radical 2 over 2. Minus The cosine of pi thirds, that's nice. If I already know the sine is square root 3 over 2, then I know the cosine is 1/2. And the sine of pi fourths is square root 2 over 2. I love when pi fourths is in my problem, because then I don't have to really worry too much. Okay? And then you just got to simplify this. Now, for these fractions, you can multiply across on the top because they're both square roots. It's just the square root of 3 times 2, which is 6. And then in the denominator, 2 times 2 is 4. And then you have minus the square root of 2 over 4. And hey, I lucked out. I already have common denominators, so then I'm just going to subtract in the numerator square root 6 minus square root 2 all over 4. And I'm answer. An exact value of sine of pi 12ths. Now, square root of 6 minus square root 2 cannot be simplified because they are not like terms. Remember that in order to add and subtract radicals, they have to be exactly the same. Does anybody have any questions about what happened on that problem? Okay, look over at the problem next door. We want to find the exact value of this expression. And there's really like 2 ways to do it. What's the most efficient way? I'd like to know. So have a quick chat with your group before we write anything down. What are ways that you could solve or find the exact value of this expression? Thinking about your formula. Okay, I heard Elise ask a great question of her group. What did you just ask your group?
I said, isn't it already in the formula?
It's already plugged in. Okay, so on this particular problem, what I would do is I would work backwards. I heard a lot of groups talking about, like, just do the work. You can do that. You're going to do more work than I'm going to do. So what I'm going to do is I'm going to look at this. This is a sine times a cosine minus a cosine times a sine. That's a difference of sine. It's for the sine formula, and it's a difference of angles. Okay? So I'm going to say this is really just the sine of 120 minus 60. Expanded. And then what's 120 minus 60? The sine of 60 is square root 3 over 2. So in that particular problem, if I take a moment to look at that formula and think about it backwards, if it's already an angle on the unit circle, that's faster than anything else you would do. So you could do the long work. What's the sine of 120? What's the cosine of 60? And then do all that work and subtract. And it's going to simplify to be square root 3 over 2. But I'm just thinking, if you notice that it's an angle from the unit circle, why do all the work?
Isn't sine of 60 1/2?
No, that would be the cosine of 60. The coordinates at 60 are 1/2 comma square root 3 over 2. And the sine value is the y. Yes, ma'am.
Did you get the sine and then multiply by 60?
Because I'm thinking about this formula, this is the sine of u times the cosine of v minus the cosine of u times the sine of v. And that, if I think about the formulas, right, because we're really looking at formulas today, that is the sine of u minus v. If I look at the front of my foldable, that formula looks like the top one. It doesn't look like cosine. It's not cosine times cosine. Certainly doesn't look like tangent. And then because it's got the minus sign in between, I know it's the difference of two angles. So if I subtracted them and then it wasn't a nice angle and I was supposed to find the exact value of it, then I'd probably have to go through and actually do the work. But if it's going to be an angle in the unit circle, that's going to be shorter. Okay, simplify this expression for cosine. So we're on the second flap. Now, there will be some problems like this that you work, and notice that when you're looking at your u and your v in this problem, u is not really an angle, right? It's just like a variable angle. So that means that in the end, you're not going to get to like a number answer, like square root 3 over 2 or square root 6 minus square root 2 over 4. You're going to have some kind of sine or cosine or trig function left over. But still, plug into the formula. So we're going to do cosine. What happens first in a cosine formula? Cosine times a cosine of u times a cosine of v. So that's cosine of theta times cosine of 3 pi over 2. And then what operation sign will we choose for a sum of angles? A minus. In cosine, yeah, a negative. It's the alternating sign because the left side says plus minus and the right side says minus plus. And then you do the product of the signs. Sine theta times sine 3 pi over 2. Now, only a few of those will I actually be able to evaluate. So like cosine theta, I can't do anything with that. But what is the cosine of 3 pi over 2? 0. And then sine theta, left alone, what is the sine of 3 pi over 2? Negative 1. And then cosine times 0 is 0. Negative sine times negative 1 is a positive sine. So this all equals sine of theta. Now, an interesting connection for you to make on this particular problem, if you think back to chapter 4, remember how we graphed the different trig functions? So what this would be like you started with a cosine graph, and remember on the y-axis it would be at its maximum, and then it would come down to its minimum and go back up to its maximum. That would be like one frame of the cosine. But this cosine graph has a theta plus 3 pi over 2. So then that cosine graph is getting shifted to the left, 3 pi over 2. Okay, then you put your cosine graph there. If then you continue the cosine graph and you keep drawing it, when it crosses the origin, it's going to actually look like sine. So the cosine graph shifted left 3 pi over 2 will end up looking like sine at the origin, where you start at the middle and you do mountain high, valley low. So it's really just like a transformation. Any questions there? Can you verify the identity next door? So this is basically similar problem, but now you know what the answer is. So we know we're going to get another sine x. Can you show me why that works? So do your formula on the left. Go ahead and do that now. If you're having questions about anything, raise your hand now. No, the plus and minus in the formula take care of all your positive and negative signs. So you always assume that angles are really positive. No. U is pi halves, V is x. Did it work out? Great. So this is going to be your U, and this is going to be your V, and then you're just going to plug it in. So you're going to do cosine of pi halves, and then cosine of x. Yeah, that's what a formula does. Okay.
Yeah, I saw that.
Okay, as I was walking around, peering over your shoulders, I was very impressed with the number of us who got our operation signs correct. So nice job, good work. Since this is a difference of two angles in the cosine, we're going to have a plus in between the work. And then we just have to evaluate the cosine of pi halves is 0. The sine of pi halves is 1. Simplify, and you get sine x equals sine x. You have verified the identity. Okay, so that kind of takes us back to what we did in section 1 and section 2. Any questions there? Okay, next up is tangent. We have tangent of theta plus 3 pi. You kind of know what to expect on this problem. You guys are distracting me. Kind of know what to expect on this problem because there's a theta in it, so you're not going to come down to just a number answer at the end. You're going to have some kind of trig function, most likely a tangent still at large. So plug in. Since this is the sum of two angles in the numerator, if I follow my formula, I should do the tangent of theta plus the tangent of 3 pi. And then in the denominator, follow my formula. 1, change the sign, minus tangent of theta times tangent of 3 pi. Are we okay with that substitution? Okay. So really we've got one job here. What is the tangent of 3 pi? How do you calculate that? Use a coterminal angle, subtract 2 pi, so its coterminal angle is pi. And so you're thinking about pi over here on the x-axis. What are the coordinates there?
Negative 1, 0.
Negative 1, 0. And how do you evaluate tangent? Y over x, so it's just 0. So this will be the tangent of theta plus 0 all over 1 minus the tangent of theta times 0. Oh, that works out pretty nice. My denominator is just 1, and my numerator is just tangent theta. Questions, concerns? Okay, last one. This is probably the one that can be the most tricky for us. A tangent, and it's not going to work out quite as nicely as this one does. So we have the tangent of 255. Think about your unit circle. Anybody guess two angles that add or subtract to 255, but they gotta be from the unit circle? No. You know, like I'm thinking to get 255, I've probably gotta use an angle maybe from the third or the fourth quadrant, but then maybe a smaller one. Like that's kind of how I'm thinking about it, but it doesn't have to be from a particular quadrant. It's just like to get that high, you can't choose just from the first quadrant. Hugh? 5 pi over 4 plus pi over 6. Can we do that in degrees? 225 plus 30. 225 plus 30. Okay, that works. Did anybody else have a different one? Okay, this is the harder version. Cool. Okay, so then we're going to put it into the formula. That'd be the tangent of 225 plus the tangent of 30 all over 1 minus the tangent of 225 times the tangent of 30. just following a formula. What is the tangent of 225? It was 5 pi over 4. So it matches pi over 4, and it's in the third quadrant, so it's positive, should be 1. Emily is saying 1. What is the tangent of 30 degrees? Radical 3 over 3. And then in the denominator, it's going to be 1 minus, I'll write this out, 1 times radical 3 over 3. And I'll just simplify that real quick. So I have 1 plus square root 3 over 3 over 1 minus square root 3 over 3. Okay, this is, in my opinion, the worst possible scenario. Because you have fractions inside of a fraction on the numerator and on the denominator. Here is a great fix for this problem. Okay? I really hope they're okay up there. Take both the numerator and the denominator and multiply them by 3. This is, for me, the best way to do it because it's going to get rid of the fraction in a fraction. But the thing to remember about this is you have to distribute that 3 to the 1 as well as to this fraction. So the numerator is going to change to be 3 plus the square root of 3, and the denominator will be 3 minus the square root of 3. But that's a quick, easy fix to make it look a little bit nicer. We still have one problem. Radical in the denominator, not allowed. So how will we get rid of the radical in the denominator? We will multiply by the conjugate of the denominator. Maybe write that in your notes so you know what you're doing. And then what you do to the denominator, you have to do to the numerator. So we're going to multiply by that same conjugate. Now, in the numerator, I'm going to actually FOIL that out and write out all my terms. 3 times 3 is 9 plus 3 square root 3 plus 3 square root 3. And then this last one, a square root of 3 times the square root of 3 is the square root of 9, which is just 3. The denominator is going to be a little bit nicer because you'll do your first terms. 3 times 3 is 9. Your outside terms will be plus 3 square root 3. Your inside term is minus 3 square root 3. That's why you did that, right? So that the radicals would cancel out. So I usually, when I'm doing my work, I usually don't write those things down. And then this one will be a minus 3. So combine my like terms in the numerator. I'm going to have 12 plus 6 square root 3 all over 6. And then that's 2 plus square root 3. You guys did a great job. I will say this. If you can avoid...
Leah Bray to the guidance office, please. Leah Bray to the guidance.
If you can avoid a 30-degree angle, if you could use a 60-degree angle instead, that may make your life a little bit easier, or a pi over 3 angle of some kind. So that's the way to work smarter, not harder on that one. But still good process.